Hey, welcome to Mulanga Tutoring session once again. Um, if you haven't subscribed or liked, please do subscribe, like the video, and comment also. Um, yeah, and I just want to say this. And if you want a one-on-one session with me online or in person, if you are where I am, please check uh, my banner or my profile. You will see my details to contact me so that we can be able to take it further. You know, um, I tutor grade 10, grade 11, grade 12, grade 9 and 8 as well, maths and science, even maths literacy. I do that. So contact me and then we can find a solution on how to improve your marks. Yes, for a better future, of course. So let's get into it. Today, we are going to talk about momentum and impulse. Actually, it's a continuation from the first video that I made about on momentum, still in grade 12 physics. So, momentum, right? We did introduce momentum and impulse. Now we're just going to do some few questions uh, from easy to hard. On this video, we're just going to do some basic questions, and then the next one, we're just going to do some medium questions, and the third one, we're going to do some like hard questions up until we go to exam question papers and previous papers and all that, so that we can get a broad view of this topic and how we can tackle it in different ways. Follow, put on like hit the notification bell so that whenever the video drops, you get you know you get the notification. So let's get into it, guys. There is something uh, a tip that I will give you. Whenever you're dealing with a topic, make sure that you know the formulas. Cramming the formulas doesn't work. You're not gonna get 100 with that. Cramming the formula or maybe relying on the formula sheet. You actually wasting your time trying to trying to cram, trying to, like, it means that you're just going to have to study some simple topics over and over again, whereas you can be tackling things that are actually hard for you. But I will openly say to you already, this topic is one of the simplest topic which you can just do once and then master it, and then you never have to read it again. Whenever it comes, you just on it. So here is how I approach, right? And which I advise you to approach it as well. Approach physics with formulas, right? So, for example, this question one says define momentum and write its formula, right? Fine. Let's start with the formula, right? We know already the P equal to what? Equal to mv. So now the definition is basically from the formula. So momentum, we basically say momentum is what? Is the product, right, of mass, right? Sorry, of mass of mass, yes, and what? And velocity. You understand? Simple like that. From a formula. You don't even have to read this thing again if you know the formula. You just use the formula to define. Simple. So let's go to the next question now. So here's the next question. Second question. What is impulse and how is it related to momentum? Like I said, approach these topics with formulas. We know, right, that momentum, impulse, right? It's what? It's given in change in momentum and also it can be given as force multiplied by the time. So you actually have to think about these two formulas when you are defining momentum and how it is related to, like when you're defining impulse, sorry, and how is it related to momentum. You can basically, you see what I did here, right? I said I equal to change in P, I equal to F change in T, right? The change in momentum of an object when a force acts on it for a period of time. That is the answer to question 2. You see how simple it is when you're using formulas. It's basically there. So, all right, let's go to the third question. So, here's the next question, right? So, the question says, like I said, use your imagination. Use your imagination, right? Number 3, a car of mass of 100 grams is moving at 20 meters per second. What is the momentum, right? So, first of all, look at the things that you are given. You are given the mass and you are given the velocity, right? The mass, right, which is 100 what? 1000, kilogram, and what? And velocity, which is 20 meters per second. And you can see that it's given in the standard form of calculation. Like, you don't need to change it. It's not given in grams. It's not or it's not given in something else. Like, these values are given in the standard form of calculation. You have to remember that. You look at that first when you are taking a question. Look the values that you're given, if are the ones that are right to be substituted on the formula that you're calculating with. Like we said, the SI unit for mass when we're dealing with momentum, it's in kgs, and then the velocity is in meters per second. So it's basically what we need. So secondly, when you're using your imagination, right, here now, you are not given a direction or some sort of a hint, or just say the car of mass of 1000 kgs moving at 20 meters per second, right? This scenario doesn't give you enough for you to even assume the direction. So you're just going to work with this. You don't write direction here. You understand? So with momentum, the formula for momentum is what? It's mv, right? And our mass is what? 1000 kg multiplied by 20, right? Which is basically 20,000, right? 20,000 kg meters per second. You understand? Simple. Simple. You got your marks. We are still building up. Don't forget direction, right? Here we don't have any sense of direction, or it's not. At least if we're given a diagram, or we're given or to east, to west, to right, to what, we can be able to work on direction. But now here there is no sense of direction, so we're just going to write it as it is. You understand? So it's going to be 20,000 kg meters per second. That's the answer. Let's go to the next question. Okay, so here's the next question, right? Number 4. Again, use your imagination. It says, if a force of 10 Newton acts on an object for 5 seconds, what is the impulse? First of all, you are given what? A force, right? Which is F, right? and then time, which is what? 5 seconds, right? 5 seconds. The object acts on, the force acts on the object for 5 seconds. What is impulse? Again, we're not given any sense of direction, so we're going to deal with it like that. We'll get to see where now we have to apply direction and all that, but it's still a vector. But right now, these are just basic questions where you don't even have to worry about that. So now, what is the formula for impulse with regards to force and time? We know, or I is equal to force over what? Change in time. And then we are given time for 5 seconds, right? And now what we're going to assume is that this thing is from rest, right? This thing is from rest. And when this thing is from rest, it means that the time was 0. You understand? So when the time is 0, what do we do now? When the time is 0, we are going to use the time that is given here on the question, right? Because the change in momentum is final time minus what? Initial time. So yeah, when we get more complex videos where maybe we have to minus the time and everything, you'll get to see. Stay with me. So if a force of 10 Newton acts on an object for 5 seconds, right, what is the impulse delivered? Force, we have 10, right, multiplied by what? By 5 seconds. So it's going to be 550 Newton per second, right? Exactly. Or you can write it as, is the same, kg meters per what? Per second. Like we said on the previous video, ns is equal to kg meters per second. Why? Because impulse equal to what? Change in momentum. They share the same units. It's basically the same thing. Let's go to the next question. So now, this is something that we didn't talk about in the last video, and it was intentional because we have to build onto this thing. We cannot start here and then, we have to build. But as the last question, I will basically introduce this topic, this concept in momentum. The principle of conservation of momentum. What is the principle? How do I state this? It states, right? It states, right? The total momentum of an object, the total momentum of an isolated system remain constant, right? So what does this mean? What does this mean? It means, Uri, when two, okay, let's throw a scenario. When two objects, right, these are objects, when two objects, right, let's say I'll draw them in a circle, object 1, right, and then object 2, right, collide. Either way, let's say this one is moving in this direction and then this one is moving in this direction. When these two objects collide, remember, each and every object is coming with their own momentum, right? So we have object number 1, which obviously has mass, number 1, and then this one is going to be, because we named it 2, it's going to have mass number 2, right? All of them are going to have their momentum, right, when they collide. So they're coming into each other. The formula for momentum is still P, right? So because we are dealing with the initial situation, so it's going to be Pi, right? And then M1, right? V1, right? And then now for object 2, the momentum that is going to come up with, still initial momentum, is going to be M2 V2. This is just naming. Remember, this is naming so that we know what we're dealing with when we calculating. So when these objects are coming together, they're going to collide, right? And when they collide, something is going to happen, right? But what is being said by the principle of what? What is being said by the principle of conservation of momentum? The total momentum of the isolated system remain constant. It means even when these objects are coming together and are colliding, the results of this collision, right? Sorry, bear with me. The results of this collision, right? The results. Let's say one object number 1, because they collided, ended up moving in that direction, right? Still 1 is M1, right? Still number 2, right? M2, object number 2. This one, let's say, is moving in that direction. So this is the initial what? Let me change the color. This is the initial situation, right? And this is the final situation, right? After collision, this side is the final situation, right? Final, right? And then this side is the initial, right? Initial, right? Sorry for that mess, but bear with me. So these objects still have momentum, all right? The momentum is conserved, obviously. The momentum is still conserved. So what does the principle state? It states that the momentum remains the same, but now these values that we got here for these objects, the momentum that we got here, in total is still going to be the same, but maybe different depending on the mass and the speed of these objects when they collided, right? So what am I saying? What is this statement saying? Okay, let's do this. So like on the first situation, so we still have, we're going to say PF equal to what? M1, right? Now we are going to say V1, right? In the final situation. Again, M2, sorry, PF for the other object is going to be M what? M2, V2. But initial, final. So bear that in mind. So as we finalize this, what do we mean by remaining the same? It means P, the momentum P initial, right, is going to be P final, right? So we have two objects, right, which have is M1, right? And then V1 initial, right? Plus M2 V2 initial. It's equal to M1 V1 final plus M2 V2 final. That's what conservation of momentum means. It means the momentum is still going to stay the same. Maybe the velocity is different because of the collision, the speed is different, but the momentum is going to still remain the same, but in a frictionless surface. Don't forget that, in a frictionless surface. That's the most important part. So thank you for again tuning in, and as we continue with the topic of momentum and tackling more questions, I hope you have hit the notification bell so that whenever I drop the video, the next video with more questions and answers, you are going to be there. Thank you for joining me again, and if you haven't subscribed, subscribe, like the video, and drop a comment. Thank you so much.